Hey everyone, and welcome to this third lecture in the series of lectures on inequalities. We started off with this topic on linear equations, the inequalities, and we continued with the introduction of it and the basic symbols that are used in linear inequalities. We described what inequality means and what does inequality means, and in this video, in this lecture, we'll be continuing with that, and we'll be wrapping up the linear inequalities in one variable, and then we're going to continue into two variables and how to graph them. So this is what we basically went through in the last lecture. Any equation that has the equal sign in the equation, that is the left hand side is equal to the right hand side, we call it an equality. Anything else than that, we will call it an inequality. You don't have to worry about whether it's greater than or equals to. As long as it is not just equals to, then it means that it's an inequality. These were the symbols that we saw, the symbols of inequality. The first one we saw was as shown in the second slide, that is the left hand side is not equals to the right hand side. This symbol represents non-equality. This basically represents inequality, and it means non-equals to. Over here we continue with this and we get the new symbols, that is greater than and less than, greater than and equals to, and less than and equals to. So we went through these symbols in the previous lecture. The bigger side of the sign is on the same side as a bigger number. This is just one of the ways to remember that, like if you can't translate this into English, it basically means that the bigger side is the one with the open side. So it basically shows the side with the larger number on that side. So that side will have that opening of the symbol on that side. For example, if 15 is greater than 10, you see the opening is on the 15 side because 15 is larger than 10, bigger than 10. And on the other hand, if you see negative 4 is greater than negative 12, we know that because in the negative, the lower magnitude number is higher than the higher magnitude number. So in the negative, we have negative 4 is greater than negative 12, and this is what we get out of that. So moving on. Now this is just pretty basic stuff that you already know. 5 is greater than 3. This is how you translate it into math. 7 is greater than 2, and this was what we have done in the previous lecture. So now the main thing that we want to discuss in this lecture is the number line. How do we graph a particular number on the number line? This is how we're going to graph a linear inequality in one variable, basically on the number line. So we know what a number line is, basically a line with numbers on it. And if you want to graph any point on the number line, for example, x equals to 5, we just put one dot over here, one circle over here, and you get x equals to 5. Now what we want to do is we want to graph inequalities on the number line, and this is how we do it. For example, let's start with the basic one, the really basic one. I messed up this slide in the previous lecture, so I'm making up for it in this one. So you have x equals to 2. This is what you get. You just put a closed circle on a particular number. Now if you have x equals to less than 2, now since we only have less than 2, first of all, there are two things we have to note on this. First of all, it means that all the values of x which are lesser than 2. What does that mean? That means 1, 0, negative 1, negative 2. Of course, it also means 1.5, 1.9, but like I said in the previous lecture, we would only be concentrating on the real numbers for these topics. So the real numbers that are less than 2 are actually 1, 0, negative 1, negative 2, all the way up to negative infinity. So this is the first thing that we have to know. The second thing is that it only shows less than 2. But we have a circle on 2. So how do we know that the 2 is not included in what we are trying to plot on the number line? The way to do that is that you represent this less than 2 with an open circle. This will show the person who is looking at the number line, or the examiner, or the person who's checking your exam, that this 2 is actually not included in this. So the value of x is less than 2. Now if you want to include 2 in it, and if you want to say, for example, the value of x is less than and equals to 2, which basically means that the value of x is going to be 2, 1, 0, negative 1, negative 2, negative 3, 4, 5, all the way up to negative infinity. The way to show that is that you draw a solid circle, which would tell the person looking at the number line that 2 is included in this, that x, the value of x is actually 2 as well, and all the numbers which are lesser than 2. Now if you look at the third one, x is greater than 2 would mean the values of x which are greater than 2 but not 2 itself. So what you do over here is that you get you draw an open circle over here to show that 2 is not included in the value of x. The value of x, it does not include 2, so all the value of x which are greater than 2 would only be there. And if you want to show that the x does indeed include 2 in it, you would show that by the help of a solid circle. Now if you want to graph this, x is less than or equals to 2, so just like I told you in the previous slide, that the way to do this, that there are two things that you need to infer from there. The two things that you can get from this above value of x, that is x is less than or equals to 10. With that, the things that you can get is that x, the value of x would be 10 and all the values lesser than 10, all the numbers lesser than 10. So this is how it is represented with the help of a solid circle. Just like that over here, since it is only greater than -4, we will only have an open circle because we are not including -4 in it, and all the values of -4 greater than -4, which would include -3, 2, -2 and -1. Just like that, greater than 200, once again a solid circle, an open circle, not a solid circle, basically an open circle, and you would get all the values of x that are greater than 200 but not 200 included in it. And once again, in order to make it perfect, in order to make it perfect for you to understand, this is how it is shown, that x greater than or equals to 7, which basically means that the value of x would include x 7 and more than that. So you show that with the help of a solid circle. Now for this slide, I want you to only concentrate on the problem that is written over here, 5, 6, 7. Don't concentrate on the inequality, just concentrate on the wordings. I told you yesterday we're going to talk about problem solving with inequalities. So just if you look at number 5 over here, just stop looking at what the inequality is shown underneath the sentence. So it shows 7 is less than or equal to 3 less than 2 times a number. So the first thing that you have to remember is, since we're talking about linear inequalities, we know that it would have the form of ax plus b, which basically shows that it's going to have one unknown variable, and that unknown variable is going to be x. So it says over here 7 is less than or equal to, now with this you can infer this sign over here. The way to solve these questions of these type is that you look at the statement and you break it down. You look at what is available to you. Now it says first of all that 7 is less than or equals to. Now it's basically, from this you can infer that there's 7, it is less than and equals to, which shows this, then some number. That some number, what is a some number? That is 3 less than 2 times a number. Now 3 less than 2 times a number, less than over here means subtraction. 2 times a number. So if you have a number, let's just say you take any number, you take n, you take an a, you take x. You take that and 2 times the number, you basically multiply it by 2 because it says it's 2 times the number. So you're gonna get 7 is less than or equals to 2. Once you're done with that, what you do is that it says it is 3 less than that number. So you already have 2 times the number, which is 2x, and then you get, how do you get 3 less than that? You just subtract 3 from it and you get this inequality. Just like that, let's move on to the next one, to number 6. Don't look at this inequality right now. The sum of two numbers is greater than 6 less than the first number. So now you have two unknown numbers over here. So, and it also is straightforward. It says that sum of two numbers. So you take any two numbers, you take x and y, you sum them like it is summed over here, x plus y, and it is greater than, only greater than this symbol over here, and 6 less than the first number. So the first number that you took was x, so you put x over here, and 6 less than would mean that you subtract 6 from it. So this is how you're going to get this equation. Now let's look at number 7. 11 more than a number divided by 5 is less than 18. Now thus far we've been talking about 6 less than a number, 3 less than two numbers. Over here we're talking about more, 11 more than a number. So if you look over here, how do we do this? First of all, what we get is that we basically choose a number. So the way to solve this one is really simple. You first add something to a number, that is x plus 11, and then it says that it is divided by 5 and it is less than 18. So after you get 11 more than a number, that is you add 11 to x, you divide it by 5, and then you get 18. Then you make it less than 18, and then you have the solution to this problem. Now let's look at practical problem that you have over here. let's just say you go to you go for shopping and you have to spend $150 for the day. You buy a shirt for $25 and some jeans for $40. You also spend $5 on lunch. Now you want to purchase something else, like you want to purchase a pair of shoes. What is the value that you can basically spend that would tell you that is less than 150? Now basically what you're asking is how much money do you have to buy the pair of shoes. This is something I am pretty sure we have all dealt with in our lives. So now you see that this inequality thing is not that difficult at all. You just add everything, 25 plus 40 plus 5. After you're done with that, you just make it less than 150 and you add another x over here, another number unknown variable that will show you the cost of the shoes that you have to buy. Once you're done with that, you have this inequality in front of you. This is just like the inequalities that we've been using so far. If you would have said, okay, I am going to buy 4 things and I want to make sure that 4 things are going to be divided by a particular number that has to be less than or equal to 150. So in that case, you would have written 4x or x divided by 4, x divided by 4 in fact, not 4x, and that you would have made it less than 150. So you would know how much to spend, how much basically that would give you the total amount if you want one thing to be 150, because that would then give you the answer of x is equals to less than equal to 600, which basically means that if you can spend $150 on everything, then you can buy 4 things of $150 and say 600 would be the total. But that's not really concerned. We're not concerned with that right now, but that's also not related to this example. I was just telling you that it's really easy to deal with these sort of questions because we have already dealt with in our real life without knowing. So how much should the shoes cost? So you write down this equation and you subtract -70 on both sides. Now remember what we talked about, the law of subtraction. Since you're making the same change on both sides and it is not a multiplication or a division, so you're not going to have a sign change, you're not going to have a change of symbol over here. You're going to get x is less than or equals to 80. Basically the shoes must cost less than or equal to the amount you have left, that is $80. Once you're done with that, we have the solution to this equation. Now let's basically try to find out, have you really understood it? If 3 is less than 9, right? So what have we already studied? We have already went through that the addition law, and that addition law basically states that if you make the same change on both sides, you're just going to get the same answer once again. So we already went to the subtraction law in the previous one. Now we're going to the addition law, and we have 9 plus 6 and 3 plus 6 on this side, and we have less than 9 less than 15. This is the same thing that we already went through in the previous slides. So far in this slide we are going to wrap up this topic of one variable, and this is what we have studied so far, that the biggest number, don't forget which the number is the bigger one, the one which has the bigger side of the symbol on it. And the second thing that you have to remember from the previous lectures is that when multiplying or dividing by a negative number, you reverse the inequality sign. This is what we talked about when we were talking about the rules of arithmetic. For this we talked about that addition and subtraction changes that are going to be made on both sides are not going to change the inequality sign. On the other hand, if you multiply and divide by a negative number, that's going to change the inequality sign. -5 x by -5 and 15 by -5, you're going to get x is less than -3. This is what your answer is going to be. So if you want to solve this, let's just say we have m plus 14 is less than 4, and we want to find a solution to this and then graph it on the number line. What we're going to do is we're going to make the same change on both sides, that is the change of subtracting 14 from it. So we're going to get m is less than -10. Now since it's less than -10, it's not less than equals to, so we're going to have an open circle that will show that m is less than -10. On the other hand, if we have this equation, -7 is greater than or equal to y minus 1, we have this equation in front of us that basically shows -6 is greater than or equal to y. And since over here, if you look at this, basically we're not doing anything special over here. We're not multiplying or doing anything special over here. We just moved y to this side, -6 to that side, to show it on the number line. That is all. And since it is less than or equals to, we have a solid circle over here. Now over here we have a new example, that is k by -3 is less than 10, and since we are multiplying it by -3 on both sides, this is basically something that we have already discussed about. So what we're going to do is we're going to change the inequality sign. Since k was less than over here, and since we multiplied by negative integer, k will now become greater than, and since it will become greater than, it's going to have an open circle and greater than -30. That is going to be the answer to this question. And over here we have with us another example, 2x plus 1 less than equals to x minus x plus 1. We first subtract x on both sides, then we subtract -5 on both sides. We get this new answer of x then less than x is less than or equals to -4. So this is pretty much it. It's pretty straightforward. If you just break it down and you do it in a step-by-step function manner, this is really straightforward to solve the questions related to this. And one of the reasons for that is that you've already been using this in your real life as well. So this is pretty much it for linear inequalities in one variable. We're going to start with the linear inequalities in two variables and how to graph them in the next lecture. So hopefully I'll see you then as well. Thank you very much.